Okay, we should be recording again now. Good. Good day, everybody. Welcome to today's session where we're going to cover predictive video analytics. And we have a very special guest today from Nokia, and it's Daniele Brancato, and he's from the Advanced Cognitive Analytics team at Nokia. And so we have the pleasure of him being able to talk about their solution around predictive video analytics, along with, in some cases, support from the Gigamon visibility and analytics fabric. So Daniele, over to you.
Thanks a lot, Gordon, and welcome all to this session. I am pleased to show you today what Nokia is able to do, also thanks to the new features introduced by Gigamon. And today we will look in particular to the video analytics solution. And this is, let's say, one of the hottest use cases we are running in the Nokia analytics domain. So the video analytics is definitely an important topic because most of traffic of the mobile networks is video, and definitely we need to have a way to understand the quality of experience of video. So today video is most of the time encrypted, and there are several ways of encryption, SSL and QUIC, and not traditional methods for determining the quality of experience are not sufficient for that. Nokia is using the new recommendation from ETSI, the 103488, which allow us to identify the quality of experience on live traffic through the user experience, the audio, video, the transport, and get scores similar to the MOS from 1 to 5, but as well precise indication on the number of freezes, the duration of the freezes, number of play delays, duration of play delays. As well, we are able to identify the video resolution, the transitions from positive to negative video bit rates. We can get a lot of information related to the CDN performances, to the user bit rate, and as well the payload, and many more that you will see later. Such information, as you may imagine, is essential to determine the start of our analytics journey, but is not sufficient because we need an end-to-end approach to identify the root cause for poor video. Because mobile network, as you know, is composed by the device, the RAN, the transport, the calling, core, and then at the end, the CDN. So we have lots of domains that needs to be covered to understand which is the performance of your video. So our solution is, let's say, today having a uniqueness in the sense that we are probably the first company who are able to do end-to-end video analytics, and we are able to not only identify the quality of experience of encrypted video, but as well to identify the root cause analysis from an end-to-end perspective. To do so, we are taking the data not only from the user plane, but we get layer 3 data, we get OSS counters, we utilize the configuration management parameters to identify how the eNode Bs are or GNode Bs are parameterized, and as well we get some information related to the devices as well. Such solution is definitely driveless and probless. This statement about probless is really because of the new Gigamon feature, which allow us to tremendously reduce the amount of traffic on the S1U, as you will see later on. And we will not bring any new probe in the customer network. So the solution is also quite important because we are making use of artificial intelligence, and this is, let's say, one of the important pieces of the predictive video. And artificial intelligence is used here to not only run the detection of the quality of experience, but as well for the root cause analysis in the data-driven model, and as well on the gene enrichment to identify the location of the users. Such solution is definitely multi-vendor, and we are in fact able to run it on all the major run vendors. So not only, of course, Nokia, but Huawei, Ericsson, Samsung, and recently also the ORAN Altiostar. So we are also ORAN compliant in this sense. We utilize today Microsoft Azure Cloud to run the use case. And thanks to the power of Microsoft Azure, the use case is definitely scalable, and we can run it over very large networks. In this slide, you are watching the components of the solution architecture for the video analytics solution. As I was mentioning before, the main sources of the data are the layer 3. So we get the possibility to identify the layer 3 messages from the 5G NODs or LTE NODs, and those are typically taken through a data collector, and Nokia has the capability to detect through a cell trace parser the messages from those data collectors and transform those messages into a readable format. And sometimes we also activate the feature for minimization of direct tests, which allow us to get the UE GPS position to identify with an accuracy of up to 10 meters the position of the users while watching the video. And we get the USS, and as I was mentioning, we need definitely some of the counters, especially on the core transport, the calling side. We utilize those to complement what we get from the run, so on the layer 3. And finally, we have the Gigamon VAF node, which is actually taking the user plane data, and these data sent through the IPFix protocol will be analyzed on the video software that will detect the video impairments and the quality of experience. The software will produce a CDR that is then sent together with the USS data and the layer 3 data into the cloud for the post-processing. So we were mentioning the Gigamon VAF. So why this solution is what we call probless, and which is the benefit that we can get while using this product. So imagine that we have today a network where in the data center we have 100 gigabit per second throughput in the PC hour. So through the Gigamon, we are able to reduce the traffic to 6 gigabit per second. So there is a 94% reduction of the overall data. Furthermore, of these 6 gigabit per second, or 6% of the input traffic, the video software that is taken from our partner NTH through this high-C software, we reduce furthermore the traffic of 2.7% of the IPFIC traffics. And then the CDR will be sent to the PVA in Azure to run together with all the other data. Once we are in Azure, there are several components here. In this picture, you see how the use case is run. So which are the components that we utilize in Azure to run the use case. So definitely we utilize the data factory, the HD Insight, the storage account. We, of course, do the queries to the query engine. We utilize Ashpash superset for the visualization, Prometheus for the monitoring. And from the browser, the customer and as well Nokia employees can browse over the use case output in a way that they can get anytime the insights or video analytics. So this is the landing page of our use case for once we get the data and the user will connect through the web browser to the use case in Azure. It will land here. So we will have this page, and there are several aspects that I will show you in a second with a live demo of it. The video analytics solution is, of course, tailored to detect the quality of experience, to detect the issues, but as well to mitigate those issues. So one of the positive aspects of running video analytics is the capability to identify precisely which are the issues affecting the poor quality of experience and correcting those. Here is an example on a Tier 1 operator in the US where we run a 12 weeks project, and on that project the focus was on YouTube and Netflix, and here the improvements were tremendous, so we could actually improve very much the sessions with freeze on YouTube and Netflix up to 65% or 68%. We actually decreased the average play delay and as well the video bitrate transitions. When we actually do the optimization on video, not only the video users are impacted, but typically as well all the other users. And here is an example of some counters related to the color aggregation utilization for all, of course, our users that are not just video. And you can see a very big improvement on the payload and the utilization of the throughput and the less interference in the power rail. Just to say that this solution is touching, yes, the video experience, but whenever we put our hands into the network, we get as well very good KPIs for general network performances. All right, so what Nokia is offering, this is an important aspect as well. So we actually provide remote access to the use cases. So in this case, on the video analytics use case, and we can provide a daily dashboard for the visualization of the quality of experience and as well the impairments. Then we provide this video QA support, which is important because we know very well that the video providers are actually changing content or launching new applications very frequently. So definitely you need to adapt your software for the detection as well for the analytics visualization later on. So we are always actually adapting the software in a way that we are always able to detect the most recent OTTs and as well detect the most recent protocols for video. And another important aspect is the flexibility to add new algorithms and features on top of the existing. So this is a use case that is always evolving, and we actually have an aggressive roadmap, and we are able to always add new content with interesting features that can bring value to our customers. There is at the end also to say that Nokia has a cognitive collaboration hub in place so that we establish a partnership with the biggest operators in order to customize the use case together or eventually even build new use cases from scratch. All right, that was my last slide. I will rapidly show you the dashboard so that you can have a look on it. So I just am on the landing page, and here, as you see, the user has different menus. You have the QA insight, the RCA analysis, the CDN analysis, data-driven insight, MDT analysis, trend analysis. Whenever you are here, you can always play with the time range, start time, stop time. With the application selection, you can actually be able to crunch the data per single cell or per a cluster of cell or per market. You can decide as well on which viewpoint you want to aggregate the data. It can be for a band, for an application, per operating system, per QCI. And then you see the results of the data set you're loading here with the total number of detected sessions, how many cells, how many freezes, how many delay, etc. And then on the scorecard, you get the information related to the split of the traffic per application, per carrier frequency, per QCI operating system, and finally you get the QE score. There are a lot of information here, and I'm not able to show all of them in this session, but let me say that the most relevant aspect of the video analytics solution is to provide the end-to-end root cause analysis, which is allowing us to detect issues. On the RCA analysis, we have a very powerful engine to actually detect the issues related to a single application or multiple application, or on a single cell, on a band, or per event. So you can actually troubleshoot only the freezes or the play delay or the negative video bitrate. And while doing so, you are always able to actually detect the different signatures. So this is, let's say, a very important aspect. So here we are, let's say, having an example of the activation of the signatures that are affecting the poor quality of experience in general, where you see the normalization of the signature to 100%. And these numbers that you see in the histogram are actually telling us which are the most common features, measurements that are being flagged while having a QE impairment. And we have a long list of issues that can be detected. And as well, we have here the CDN information, so that whenever there is no radio issue, we can see as well which is the CDN having the impact. This is one just of the example. We have a lot of engines here. You can see that we have the word cell analysis, the KPI analysis, the rules ranking, the statistical analysis, the RCA data, where you can get every single video streaming session with all the measurements taken in the end-to-end way. So this is, let's say, a very powerful methodology. I rapidly go show you the CDN analysis that is also, let's say, an interesting aspect because the CDNs are also on the high while looking at the video performances. And here the users can always identify the issues related to the latency, to the time to first packet, to the uplink and downlink transmission, failure rates. They see the impact on the freeze view and play delay. And there is a kind of anomaly detection algorithm running that is always telling us which is the best performance CDN and which is the worst. And then we will know exactly from the IP address who is the owner of that CDN, and this can be helpful on the troubleshooting. It can actually have a huge impact to all the video users. I have, let's say, very short time left. Just a short note on the data-driven model, which is the very end-to-end methodology. Here as input, we actually put all the end-to-end data, so the layer 3, the OSS counters, the video QE, the CM, and the data-driven model is telling us which are the thresholds for the detection of the problem from the end-to-end perspective with higher accuracy and confidence and high support. So this will tell us, for instance, which is the CDN having issues, or which is the P gateway, or which is the MME, or which is the transport link, or which is the InnoB measurements in terms of RSRP, throughput, SRSI thresholds that are actually causing the issue in the network. All right, I think I was fast, but I gave you, to say, an overview of what we are doing, and I hope you are appreciating this job and cooperation together, as I'm pretty sure that this partnership will allow us to actually spread the video analytics solution and Gigamon solution all over the world. Thank you very much for listening. It's all for now. I wish you a good day.
Well, thank you very much, Daniela. That was really exciting and interesting stuff about what you're doing there with the predictive video analytics. So everybody, thanks very much. We'll hand off to some Q&A in a second, and thanks very much for watching.